All right, here we go, guys. I'm going to get started. I definitely probably did way too many examples again, but we are continuing with the graphs of the polynomial functions. I wanted to do one more day just to kind of review what we did yesterday before I threw anything else new at you guys. So today should just feel like exactly what we did yesterday. We are creating these graphs by finding their x-intercepts and using their end behavior to kind of fill itself in, all right? I put the end behavior rules at the top of today's notes, just so again, you have them right in front of you if you needed to refer back to them, okay? But let's go down to example 1. Let's jump into a graph. Oh, what did I do? All right. So if you're gonna graph or sketch, remember, we're just sketching. These are just rough kind of ideas what these graphs look like. The most important points on the graph, though, are its x-intercepts. That's kind of where we want to start. So we want to set the function equal to 0, and let's start solving. Let's get those x-intercepts. Now, just like yesterday, I've given you all of the polynomial functions in factored form. So when you set it equal to 0, you don't have to factor it. It's already factored. Let's just start setting our factors equal to 0. Guys, if you set negative x equal to 0, divide by negative 1, you're totally getting x equals 0. Everybody pause, everybody look up here at me. I have had the chance to look over everybody's homework so far in my first 3 classes that submitted it. Not everybody submitted it. But out of all the students that submitted it, thank you, Jocelyn, I appreciate it. You only have an x-intercept at 0 when you have a single factor of x out in front. Guys, you're not going to get x equals 0 when you set this factor equal to 0. You're not going to get x equals 0 when you set this factor equal to 0. You only get x equals 0 when you have these single factors of x that you set equal to 0. I had a lot of students saying that they had an x-intercept at 0, but they didn't have any single factors of x. So please be careful and don't create an x-intercept at 0 when there really isn't one. All right, let's go to the next one. Guys, if you can't figure out what x would be when you solve that, when you set it equal to 0 in your head, then maybe you got to write it down and solve it. When does 2x plus 3 equal 0? Minus 3. 2x equals negative 3. Divide by 2. X equals negative 3 halves. Now, guys, remember, at the end of the day, these are the x-intercepts. These are the points that we're going to put right on the x-axis. Everybody agrees that decimals are easier to place on the x-axis than a fraction, probably. So ask your calculator, what's negative 3 divided by 2, and get the decimal so it's easier for you to plot. It's negative 1.5. All right, perfect. Go to the last factor, set it equal to 0, and I get x equals 4. So you get these 3 completely different x-intercepts. Let's throw them up there. Try to space it out so you don't create these tight turns. All right, we got one at 0. We got one at negative 1.5. So anywhere in between negative 1 and 2, you're good. Negative 1 and negative 2. And then we got one at x equals 4. Okay. Now we need the y-intercept. That's the only other official point they ask you for. The y-intercept, though, guys, I told you yesterday, the minute you have an x-intercept of 0, what do you already know the y-intercept is going to be? 0. All right, but I'm going to go through the motions just in case anyway. We get the y-intercept because x has to be 0, so we plug 0 in, and we get a negative sign, which is negative 1, times we plug a 0 in, times 2 times 0 is 0, plus 3 is 3. 0 minus 4 is negative 4, but really, guys, who cares? Because the minute you have a 0 in here, when you multiply that together, I swear to you, you're getting 0. So your y-intercept is definitely 0. Okay, now we got to figure out this darn end behavior, right? Is it up, down, who's up, who's down, what's going on? In order to do that, you need that leading term from that polynomial function. But remember, when I give it to you guys in already factored form, you didn't get to see that leading term. So we have to create it by multiplying all of our fronts together. So start in the front. Negative x times 2x is negative 2x squared. Times the next front is negative 2x to the third. So guys, I promise you, if I gave you this polynomial function in standard form, all multiplied out, it would have led with a negative 2x to the third. Which means, what's the degree? The degree is 3, which is odd. And now we know the end behavior has to be different. One up, one down. who's up and who's down depends on that leading coefficient. The leading coefficient is -2. Guys, it's negative. So if your ends have to be different, and the leading coefficient is negative, does anybody know which one it is? Is it up on the right, the positive side of the graph, or is it up on the left, the negative side of the graph? Left. So to the left of your last x-intercept, your graph has to end up. And when I say up, guys, I mean it has to end above the x-axis. So give yourself a target. To the right of your last x-intercept, it's got to end down below the x-axis. So give yourself a target. All right, I'm going to give you guys 10 seconds. Fill that graph in. What does yours end up looking like? And then I'll fill mine. And again, we should all probably look a little bit different, but there are details that are always going to be the same, and that's what matters. All right. I start left and I work my way right. It has to end up here, so I start up here and I head towards the first x-intercept. All right, guys, this x-intercept, it did not repeat. It doesn't have a multiplicity, which means you just cross right over. I'll show you those other ones tomorrow. All right, so we cross over. Now my graph is going down. I don't know how far down it goes. I don't really care. I just know that my next dot is now up there. So eventually this graph is turning somewhere. So make it turn. Nice and smooth. Now I get to this x-intercept. This x-intercept didn't repeat either, so just cross right over. No multiplicity. Now my graph is going up. I don't know how far up it goes. I don't really care. I know that my next dot is there, so it's going to turn somewhere, so make it turn. All right, I get to this x-intercept. That x-intercept did not repeat. It does not have a multiplicity, so cross right over. Guys, you have run out of x-intercepts, so I don't have to head towards another dot, and it's supposed to end down, so leave it down. And your graph should look something like that. Okay, remember, these are just sketches. All we're able to take away from this is the fact that I now know that if I plug any x values over here in, they make a positive y value come out. If I plug any of these x values in, they make a negative y value come out. If I plug any of these x's in, they make a positive y value come out. And if I plug any of these x's in, they'll make a negative y come out. That's all we care about. I don't care about what y actually comes out. I just care that this is positive and that one's negative. So as long as your graph is positive, negative, it's perfect. Okay? All right. Now they're going to ask you to describe the end behavior in like that fancy math language I was telling you about. This box is asking you to describe the end behavior. Okay, so they're asking you to fill two things in. The only thing you are ever going to fill in is either a positive infinity symbol or a negative infinity symbol. That's all they're looking for. All right, so guys, this is how it goes. It says as x goes towards positive infinity. So as x heads towards positive infinity, meaning as x gets bigger and bigger and bigger and bigger. What is f of x? What is this function doing? Remember, f of x is the y coordinate. What is the y coordinate doing? So as x goes to infinity, they're basically saying, what is the right side of the graph heading towards? So guys, as x got bigger, what did f of x do? Did it go down or did it go up? Down. It went down. So is it heading towards negative infinity or is it heading towards positive infinity? Negative. So it's heading towards negative. The y coordinate is following the y-axis all the way down towards negative infinity. So it means as x gets bigger, f of x is getting smaller. So the bigger x values you plug into this function, the smaller output it creates. All right, last. Let's go to the other side of the graph. As x goes towards negative infinity, so as x gets smaller and goes towards negative infinity, what's this end of the graph doing? Is f of x going up or is f of x going down? It's going up, so is f of x heading towards positive infinity or negative infinity? Positive. And then guys, think of it this way. This was an odd degree graph, right? The end behavior has to be different. So you should have different infinities. One end should head towards positive infinity, and one end should head towards negative infinity on an odd degree graph. All right. Woo. All right. Let's try it again. Is everybody okay so far? All right. At home, thumbs up. Okay. All right, here we go. Same thing. Guys, let's go through the motions. I'm trying to show you some different x-intercepts, though, just to kind of like jog your memory. Let's set this equal to 0. Let's start solving. All right. It's already in factored form, which is great, but guys, do you notice? These are not linear factors. These are quadratic factors. So when you set these degree 2 factors equal to 0 and solve, you should get 2 answers from them, not 1. All right, let's set this one equal to 0. X squared minus 4, set it equal to 0. You could factor it because it's the difference of 2 squares. I just set it equal to 0 and solve. All right, let's add 4. Let's square root both sides. But remember, when I solve a quadratic, I should get 2 answers. And when you take the square root of a square, it creates 2 versions of that answer. So x will equal the positive or the negative version of the square root of 4, which is 2. So you end up getting positive 2 as an x-intercept, and you get negative 2 as an x-intercept. Now, guys, they are not repeated roots. These are 2 very different numbers. All right, let's go to the next factor. Set that equal to 0. Uh-oh. I minus 1. I get negative 1. That's never a good thing when something squared equals a negative number. Let's square root both sides. X equals, I get 2 answers, plus or minus. Anybody remember who the square root of negative 1 was?
1.
What is it?
1.
Not 1. It's I. So you get the imaginary number I. Are imaginary numbers allowed to be x-intercepts? No, because they're not real numbers that live on the x-axis. So guys, get rid of them. They are not going to create crossover points for you. So all you have to worry about are the real numbers that you got. So that's just plus and minus 2. So those are the only 2 x-intercepts that we have to show. So let's put them up there. All right, we got one at negative 2, and we got one at positive 2. Notice, I did not have a single factor of x, so I don't have an x-intercept at 0. All right, let's get the y-intercept. X has to be 0, so let's plug 0 in. What do I get? I get 0 squared minus 4 is negative 4. 0 squared plus 1 is 1. Negative 4 times 1 is negative 4. So you definitely have a y-intercept down there at negative 4. All right, let's figure out all this end behavior, right? I need that leading term so I can get the degree and the leading coefficient. So let's multiply our fronts together. It led with a positive 1, guys, so don't worry about that. It's really just x squared times x squared, which is x to the 4th. So I'm telling you right now, if this polynomial had been given to us in standard multiplied out form, it totally would have led with a 1x to the 4th, which means its degree is 4, and the leading coefficient is 1. Anybody know the end behavior if it's even with a positive leading coefficient? Both up. So to the left of your last x-intercept, we got to end up above the x-axis, give yourself a target. And to the right of your last x-intercept, you have to end up above the x-axis. All right, I'm going to give you guys 10 seconds. Tell me, figure out what your graph ends up looking like. All right. I go left to right. So I have to end up here, so I start here, I head towards that first dot. So this x-intercept did not repeat, no multiplicity, cross right over. Now guys, for all I know, maybe the graph goes all the way down, turns, and it hits the y-intercept on the way back up. It doesn't matter. It doesn't matter. The important thing is that I'm down here right now. So I'm just going to head towards my next dot. All right? My next dot is up there. So clearly I've got to turn, so make it turn. This x-intercept did not repeat, no multiplicity, let's cross right over. I have no more x-intercepts to head towards, and I should end up, so stay up. Did anybody else's graph end up looking like this? Okay, does this look like a parabola to you guys? Yeah, right? The weird thing is, a parabola should be graphed from a degree 2, a quadratic function, right? This was a degree 4. Now, I'm not saying that a degree 4 can't end up looking something like this, but it's not something that we actually call a parabola because it's the graph of a degree 4. So we can't call it a parabola. But guys, remember, I'm just asking you guys to sketch it. I just want to figure out where's the graph positive, where's the graph negative, where is it positive. That's all we're taking away from this, and that does the perfect job. However, I just want to point out to you, we had some imaginary x-intercepts, right? So we had some numbers that make it equal 0, but they don't create crossover points. a lot of times when you get these imaginary x-intercepts, they do create some turns on the graph, but they do it so that, yeah, it turns, but it doesn't make it cross over the x-axis. It does all of its turning either completely below the x-axis or completely above it. So if you were to graph this on a graphing calculator, this is what the graph actually looks like. It actually looks like this. Okay, so it really does not make a parabola if you saw the real graph, but guys, it does exactly what we need it to graph. Our graph is positive where his graph is positive. Our graph is negative where his graph is negative, and our graph is positive where his graph is negative. So our sketch gets all the same information as his, but these imaginary x-intercepts, they created some turns, but the turns don't lead us going all the way back up to the x-axis. We do all the turning, but it stays under the x-axis. And that's normally what x-intercepts that are imaginary do. They create some turns, but not enough to get you all the way back up to the x-axis, okay? So just to point that out, if anybody was wondering, that's really what the graph looks like, but our sketch does the perfect job, okay? All right, let's fill in our end behavior. As x goes to infinity, so as x goes this way, where is this end of the graph going? Where's f of x going? Up or down? Up, so it's going towards which infinity? Positive. All right, as x goes to negative infinity, as x goes this way and gets smaller, where's f of x, where's y going? Up or down? Up. So it's also going towards positive infinity. And remember, guys, this was an even degree function. The end behavior should match. You should have matching infinities on an even degree graph. All right, how are we feeling? Good still? Again, I'm just trying to give you just a few different scenarios and maybe some uglier x-intercepts today. All right? Let's see the next one. All right, we start the same way every time. If I'm going to sketch this graph, I need the x-intercept. So let's start setting it equal to 0. Let's start solving. And again, guys, it leads with a negative sign, which is a -1. If you set that equal to 0, there's no variable to solve for. It's not going to create an x-intercept. All right, go to the next factor. I'm going to add 9. I'm going to square root. X equals, I should get 2 answers from a quadratic, plus or minus 3. That's really easy to forget, guys, so please don't forget your plus or minuses. All right, I come over here. I set x squared minus 2 equal to 0. Now I'm adding 2. That's a good sign. We square root both sides. I get 2 answers. X equals plus or minus. Now, normally, last week when we were solving, I would have said leave it as the exact answer. So you would leave it as plus or minus the square root of 2. But guys, you have to plot this now. You may not know where the heck the square root of 2 is. So ask your calculator, what's the square root of 2, and get me a rounded decimal. It's about 1.4. So plus or minus 1.4. So you can plot it easier. All right, let's throw them up there. I tried to space it so that I'm not making too tight of turns. I got a -3, I got a +3, I got a positive 1.4, somewhere in between 1 and 2, and I got a negative 1.4, somewhere in between -1 and -2. Don't stress out about it, just throw it in the middle, call it a day. All right, now I need my y-intercept, so I got to plug in 0. All right, if I plug in 0, it starts with a negative sign, guys, so don't forget it. That's a -1. Then I plug in 0. 0 minus 9 is -9. Then I plug in 0 squared minus 2 is -2. -1 times -9 is 9. 9 times -2 is -18. You got a y-intercept down here at -18. Okay, we got all of our important dots. Now we got to figure out what is the end behavior. So I need that leading term. So let's multiply our fronts. -1 times x squared is -x squared. Times x squared is -x to the 4th. All right, that makes this a degree 4, so it's even. So now we know our end behavior has to match, right? Both up, both down. The leading coefficient, though, is -1. So which one is it? Both up, both down? Both down. So to the left of your last x-intercept, we got to end below the x-axis down. Give yourself a target. All right, to the right of my last x-intercept, I gotta end down below the x-axis. Give yourself a target. All right, I'll give you guys a second to fill this in first. And remember, guys, only cross the x-axis where you put a dot. The amount of students that are crossing over the x-axis wherever they want is crazy to me. All right, I end down, I go towards my first one, it didn't repeat, so I cross. Eventually it's gonna have to turn and come back down. I get to my next x-intercept that did not repeat, so it crosses over. And again, for all I know, maybe it does go down and get the y-intercept on the way back up. We don't have to be that specific. I'm going for my next dot. I gotta turn, go towards my next x-intercept, which is not a repeated one, so I cross right over. Now I gotta turn somewhere to get to the next one, so make it turn. I cross over, it does not repeat, so I cross right over. I have no more dots, and it stays down, so leave it. And it should look something like that. All right, so again, now we know it's negative here, it's positive there, it's negative here, it's positive there, and it's negative there. We now know the behavior. Okay, so as x goes to infinity, what's this end of the graph going towards? F of x is going towards negative infinity. I know you can't see mine, but I'm going to write them down anyway. And then the next end, as x goes to negative infinity, as x gets smaller, f of x is also heading towards which infinity? Negative infinity. All right, and again, this was an even degree graph, guys. The end behavior should match. It should be the same infinity. All right, I'm going to ask you guys to do the last one. I'm going to do it up here. I'll probably talk a little bit through it, but you guys try to do the last one. Get your x-intercepts and see if we can create it. I got my first x-intercept to be 3/5, which I know is in between 0 and 1, but guys, get the decimal. Make it easy. It's 0.6. Now I'm letting you get decimals because they're easier to graph. I'm just going to go so that the bell doesn't cut me off, but you guys keep going on your own, and we can always look and see if we match.
You're like 5 minutes. Okay.
Do we? Okay.
4 or 5 minutes, depending on the bell.
All right. I feel like I've been struggling to get this last example in.
Mm-hmm.
All right, I get 2 more x-intercepts from my middle factor, plus or minus 2 different numbers. Well, this is never good, guys. It's never good when it's x squared plus a number, because then you're going to have to minus it when you solve, and now you're taking the square root of a negative number. You cannot say imaginary. Now again, they may create some weird turns on the graph, but not enough to create x-intercepts, so they don't count. We cannot plot them. So you really only have 3 numbers that end up on your x-axis. The y-intercept is huge. I got 336 when I plugged in 0. Okay. Got to get that leading term. You got to multiply your fronts. You got to get your degree. Gotta get the sign of that leading coefficient. I kind of just count my x's, guys. There's 2 x's there, there's 2 x's there, that's 4, there's 1 there, that's a 5. There should be an x to the 5th. There's 5 x's that are multiplying together. So 5x times x squared is 5x squared times x squared. That's a 5x to the 5th. Which means we are working with a degree 5, so odd, different end behavior, and my leading coefficient is 5, so it's positive. So that means it's up on one side and down on the other. Does anybody know which side is up, right or left, if the leading coefficient is positive? Up on the positive side, right side. And then down on the left. And remember, you're only crossing the x-axis where you put dots. Nowhere else is it allowed to cross over. See you, Deb? Oh, you're just waiting, sorry.
Not leaving.
Okay, all right. And this one, guys, it kind of makes it does make, I hate using the word sharp because nothing should be sharp. It should be nice and rounded, but it's kind of like a sharp turn. I end down, I cross over because that x-intercept didn't repeat. I'm heading towards my y-intercept. I know my next dot it's like a drop. Go through it, going down, now I gotta come back up, so make it turn, and then it stays up. So it looks like something like that. Okay?
And it's connected dots.
Yeah, guys, I cannot tell you, grading homework, people have been doing this. All right, I'll go up, I better come down, I gotta come back up, gotta hit there, then I'll come over. Why are you crossing if you don't have dots? Don't cross unless you have a dot. Yes.
Connected dots.
All right, guys, there is a new homework. I made a new Google slide that is 5 questions, and it is due tomorrow night at 11:45. Yesterday's 3 problems on Google Slides are due tonight. Some of you already did it. All right, I'm trying to comment back if I can. Have a great day. We'll see you guys tomorrow. Guys in the meet, thanks for coming. Oh, I'll fill the infinities in on the. See ya. Have a good day. You too, guys.